Hi, this is Ali, and I'd like to take a couple minutes to give you an overview of an integration we've developed between IKE and PLS-CADD. I'm assuming that you're familiar with the IKE solution, with the IKE 4 uh, and with PLS-CADD. So I'm going to start off kind of working from left to right. Gonna give you a quick look at our IKE form, this PLS integration specific IKE form, and then gonna show you a sample project that I've collected in the field using an IKE form, and then show what the integration process looks like. And that's here over on the right. And this will lead into PLS-CADD. So first, I'll give you a quick look at our form. So there's this, so it's the PLS integration form. It has these fields here, every structure. So this is what you need to fill out for every structure. So you need to provide an ID, a location, and then you have the option here to define poles, spans, survey points, and going on whether or not a head span from the last structure is this back span, and then some notes. So let me point out a couple of points here. So this poles subform, expand that out, this allows us to be able to generate PLS pole models with multiple poles. So if you have a stub pole modeled and you want that modeled in the same PLS pole model, this allows you to capture each pole separately. Another option is to treat each pole as a separate structure, and that's totally fine as well. You just create a new structure, a new IKE collection, and work through that. But this allows you, if you do want to keep those in the same model, you can create multiple poles and define them here. And I won't go through too many of the details, but just point out, here's the IKE photo that you're probably familiar with. This is the top to bottom shot of the pole. Then, with the pole, you can define anchors, equipment, cables, and joints. And so point out quickly on the joints, this is something that we added in to provide some flexibility in PLS pole and PLS-CADD, the integration side. So you can add just a generic joint in um, during the back office process. And what that will do, it'll create a joint at that location in in PLS pole, and you can snap to that joint. Um, and that's so that's a feature that we have that can be used in tandem with some of the other features. That's a brief overview of poles. Kind of quickly look in spans. So same thing with spans. So you would, in the field, you would, for every span on the pole, so for the back span, you would measure that span length and then provide this information. Same thing with the head span or any tap spans. Now, if you remember that, so there's this back equals last to head. So that will do that. Reduces the amount of work that you have to do at each pole. So if you're just going in a line, you can set this yes no checkbox to true, and whatever the head span from the last structure was, it'll set that to the back span of the current structure. So that can save you time. So when you filling this out for a structure, if you're just going in a straight line, you should just be able to put in one span, which would be the head span, grab the information, and then go ahead. So I'll touch on a couple of the sub-forms that we have here. Have wire survey points. So what this allows us to do at specific locations along the line, you can shoot wire heights, and will actually generate survey points in PLS-CADD that you can use to sag those wires to. Now we have the option to add a framing, an arm, or an insulator. So a framing, you are able to, so this is just pulling from your PLS pole framing library. You can filter it down, and whatever you add in here will be added in to the PLS pole model at a specific location or multiple locations. So the way that we have this set up, this is set up in a subform, so a location will, if you have, let's say you're adding in a framing, which is just, maybe it's a street light or some piece of equipment, maybe that appears multiple times on the structure, or I guess in this case, maybe it's a cross arm. So you have a distribution cross arm framing, and it's the same framing at different locations. This allows you to define it one time and then just add a new location to save time. Now we also have an arm builder. So this is something that we're still developing, but it's been working so far. What you do, you'll define the wire type, the arm type, and this is again coming from PLS pole, the component library. So we have all the main arm types here, and with each of those, you would here have your PLS pole component label. So it will pull that arm type, and then you can choose what insulator you want to add onto that arm. So if you want to add post insulators or strain insulators, you can come in here and choose, so like for a distribution arm, you could add in a 12 kV pins to your arm. And we have a couple more options here on how that arm would be constructed. So we have this terminal dead end that, for strain insulators, it will flip back and forth on what side, or it will, sorry, if that's true, then it'll report on both sides, and if not, then it'll just report on one side. And then here, so the number of wires and the wire layout, that's how this crossarm builder generates the crossarm. So you select the number of wires that you want. So a 2, 3, or 4 wire. Let's say you have 3 wires though, and there's where's that odd wire going to go? Is it going to go on the left side of the pole or the right side of the pole? So we have this wire layout that we use to position wires. So there's a balanced case that pushes odd wires to the right or left, and then one on the right and one on the left. And those ones will stack wires straight from the right side or from the left side. And then again, as with the framing, there's a location, so you can define an arm, and if it appears multiple locations on the pole, you can just add a new location, so you don't have to define that arm separately. And insulators, similar to arms, you sort of build it out with the wire type, insulator type. Insulator type, again, these are coming from PLS pole, the component files, so all your labels are going to match up there, and it's going to pull that in from the component file and add that onto your structure. For post insulators, you can choose if it will appear on the right, left, or both sides of a pole. And then again, locations, you can choose multiple locations. So let's say you had post insulator at 3 locations. You can define it one time and then come in here and then bring it in 3 times. So that sort of wraps up the spans. Now the survey points, this just allows you to add in generic survey points with the description, just anywhere. So this could be a wire, this could also be a tap, structure, or vegetation, obstacles, things like that. So that is really the bulk of the form so far. We're continuing to develop it, but a majority of the features are in there right now, and we're happy with what we've been able to get from that. Okay, moving on. I'll quickly show some of the form features in this portion of the demo, yeah, just wanted to show this line that I went out and fielded this morning. So if you, so there are 5 structures here, and I'm just kind of cycling through them. Down here you can also go on the map and select what structure you want. And I've already annotated this this set of structures, but I just wanted to show that process. Let me show you here. So I'll just quickly show you kind of how I constructed this pole here. So it's has transmission and distribution. So here for the transmission, there's this post insulator and on both sides of the poles at 3 locations. And then there's this there is a distribution crossarm here. It's got 3 wires, but it's balanced on the left. And then there are some communication wires down here. So how is that modeled? So if we open up, let's go into the spans, and we'll go into the head span. That's where I define these. So if you look at arms, there's an arm here. I gave it it's a distribution arm, and the arm type, insulator type is the post, that 12 kV pin. It's not a dead end. Number of wires is 3. The wire layout was balanced, odd wires left, and there was only one location where that arm was located. Now for the insulators, let's take a look there. It says we only have 2 insulators, so kind of figure out what's going on there. So we see there's a transmission insulator and then a communication insulator. This transmission one, this is the post insulator that I mentioned. The post insulator is on both sides of the pole, and in this case, it's ignore that for now. It's that's just something I used to help the model. I'm assuming that this was the first structure in the line, so I made these post insulators dead ends, even though that's not what they're designed to be. For the demonstration, that's just kind of what I had right now. So sorry for that. But if we look at the locations now, you can see there are these 3 locations. If you hover over them, it'll kind of show where they're at. So that just simplifies that modeling process. So if I wanted to start over again, which I could here, I'll just show you how quickly that could be. So you would come in here, add a new insulator, give it a transmission wire type, select the 69 kV post, make that on both sides, set it to terminal dead end, and ignore the obvious error in that. But then we would come in and add our attachment heights just by clicking on the structure. That is it. Yeah, so save the changes and move on. Now I won't go through all the details, but I'll just kind of show some of these other structures. They're all pretty similar, and yeah, so and this structure, actually, this one had you can see there's this other arm coming across perpendicular here. There were 2 structures on either side, and sorry, there's the one, and those ones decided to add those as poles. So this single structure is going to be modeled in PLS pole with 3 poles. So the way that was modeled was here in the poles subform. You can see there's pole 1, pole 2, and pole 3. And yeah, again, all the information so the heights were gathered from the IKE images, and so for if you do have multiple poles in a model, there's another field that's required. It's a location, and you can see here it's required if multi-pole. So if you do have multiple poles, you would have to snap an IKE vector. So you would target the first structure and then target the second structure. And then that's what gives IKE the bearing and the distance to that pole, which we then need the PLS-CADD integration to position those poles within the PLS pole model. And that is it. So that's all you need to do here in IKE Office. You just go through all your structures, define all the attachments, define any equipment. Oh, I forgot to mention there are a couple structures with equipment. So here there's a street light, and I think there's another piece of equipment. There's a transformer here at the end. So all you have to do is come in and fill the structure out like you normally would in IKE Office, and you are done. So once that's finished, um, you then will open up our application. This is kind of what it looks like, and again, sticking with the left to right theme, we're going to work away from left to right. So this is the IKE integration application built into our suite of software tools. So we're going to open up the settings first. We have three categories: IKE, PLS Pole, and PLS-CADD. In IKE settings, here you can provide your username and password for your IKE Office account. This is saved locally to the your Windows machine's credential manager. So it's those are securely stored in the Windows operating system. PLS Pole settings here. You have the option to define the default pole label as well as the default guy, installed tension, and then there's also the set number definition that you can define. So this is something that that can help for any of the arms or insulators that you add in manually. So if you add in framing, it's going to take the set numbers from that. But if you add in arms or insulators, we have this technique of assigning set numbers based on the wire type. So you notice here there's transmission, distribution, communication. These all match up to the wire type that we had. So like for an arm, if we look at the wire type, so these all match up to the wire types here. So based on the selection you make in IKE Office, the set numbers will be applied accordingly. Now we have a couple other options about how the set numbers are defined. So if you like to fill the phases before changing the set numbers, or just go set by set, every single attachment is a separate set number. That those two options are possible. You can leave these blank too, and the integration will just add in sets. It'll define sets based on just starting from set 1, working its way up. Anything available, it'll add that in. Next, here in PLS Pole is the component file. So you can import your component file library from PLS Pole model, and that'll populate all of these fields. And that these are used then to as references for all your pole models, and they're also saved in a directory in the resulting output. And the last section is a PLS-CADD section. And here there's some settings for structure comment generation, for the unit system, feature code, and then some standard files. So structure comments, you can add the IKE photos or pull tag photos as structure comments. Unit system, one thing that we have to do, you have to define the coordinate system that you use in PLS-CADD, and then you also have the option here to choose between imperial and metric. Have a couple feature codes for the survey points that you bring in, and then if you have any standard feature code or criteria files, you can define those. And that brings us finally to the main feature, the integration. So I'm just gonna try to run through this. So I click this Load IKE Jobs button, and based on the credentials that you have stored, it'll load up your IKE job list. So these are all the jobs that I've been working on. So we're going to open up this Kurt's job. This is the one that went out in the field this morning. It's going to download the job. Then we have a list of all the structures here that you can just review. And next step is just to export to PLS. So we'll export out onto the desktop and wait for the integration to finish. It's gonna make sure that you have PLS Pol installed. Then it's gonna go through a process of reconstructing the information from IKE, and this may take a couple minutes. Okay. Well, thanks for waiting. So here, the integration, it automatically generated and then opened up this this directory for us with some files in it and some other directories. So let's just take a quick look at what we have here. Well, there's a readme.txt. That's always usually important. So let's take a look there to start. So get some instructions here. Tells us to just open up the kurtz.xyz file, and then to match the PLS-CADD coordinate system with the coordinate system defined in the IKE integration settings. So this coordinate system here. So state plane NAD 1983 and state plane California 6. So once we've done that, then the next step is going to be open import staking table.csv, and then in PLS-CADD, go file, import staking table, copy and paste the contents, and then save the PLS-CADD model to generate the remaining files. Okay, so let's go through that process. So we have this directory now, and as I mentioned, before just jumping in there, I just want to highlight some of the files. So there's an XYZ file, criteria file, and the feature code file, as well as that import staking table that was mentioned in the README. There's also data, photos, and structures. Data, this contains all your component files. Photos will contain all of the IKE photos and then any pull tag photos. And then structures, this contains all the structures that you have. And notice the numbers here are in sequential order. That's just because that's how I number them in IKE Office. See, the structure numbers are just 1 through 5. So whatever you have in IKE Office will come out there. So let's go through that process again. So let's open up the XYZ. And then the first thing it said was to go into clearance, terrain, coordinate system, define. And we'll go to state plane NAD, California 6. Okay. Now the next step was to open the import staking table. Control A, Control C to get that into the clipboard. Come back into the PLS-CADD, the file, import, staking table. and then I'm just going to paste and click OK. The next dialog box here is going to ask, it's an automatic stringing option. So let's go ahead and try and use that. Let's just select a wire, click OK, and see, oh, 2 sections were created. Awesome. Okay, let's continue on. And now we have some more information here in our PLS-CADD model. First of all, you'll notice we now have an alignment that takes into account the line angles between the structures. Now here, there's a small line angle here, but it's not as apparent. But it will, bring in the line angle now. So let's let's bring out the 3D view and kind of take a look at what we have. So these are the structures that we modeled. If you take a closer look, you can see, okay, looks pretty familiar. It's those post insulators. This arm have the insulators balanced on the left, like we modeled. The structure here had those 2 poles, and you can tell by the compass rose that those are, this one's so big because those poles are actually a part of that single PLS pole model. So if we take a look here, go edit, you can see, yeah, those are in that same pole model. And let's take a look. If we take another closer look here, you see also some survey points. So what these are were added in. I'll show you where those were added in. They were added in the span in the wire survey points. Let's go. I think this was one that had it. Okay. Yeah. So here, so the wire survey points field. So this one. So there were 3 survey points at this location, and if we take a look here. So that was structure 3. There were those 3 at that one location. And the way it works, you define a location, and then you define a ground point, and then at that ground point you measure heights. So here there were 3 ground points that were defined and 3 heights. And these other 2 spans, there was 1 ground point with those 3 heights. Here there were 4. There was also a communication wire here that was strung in. That was the height there. But one thing we can do now, we can go in and actually graphically sag to those points that we gathered. So let's just come in here. We'll go to sections, graphical sag, and just kind of bring it down. So these are the only 3 spans that gathered survey points from. So if we kind of toggle back and forth, we can find a good spot, apply, and then grab the other wire, bring that in. And one thing working on right now is to test the accuracy of this system. I'm looking at a couple different options on getting these mid-span survey points, but for now, this solution seems to be decently accurate. But yeah, again, still testing that portion of it out. But after taking a closer look at it, believe that it is can be a valid way of sagging, getting accurate as surveyed conditions. So there we go. We just went from IKE. We went from a nice orange piece of metal and plastic to this online interface, and then finally to this desktop application which spit out a PLS-CADD model. And that model, we have all of our structures. We have multiple structure poles in a single structure, and we were also able to grab in wires and survey points for the as surveyed condition. Now the let's go ahead here, and I can also run an analysis. We're going to see this pole is pretty heavily loaded because it is not correctly designed. But we come into these interior poles, and those ones are working out a little bit better. But yeah, for the purpose of this demonstration, these two structures are yeah, it's not an accurate representation of what's out there in the field because I made those dead ends, and they're not actually designed to be dead ends. So ignoring that fact, yeah, just that's it in the overview of the integration so far. You'll still have a few more features that we're trying to add in, but at this point we're getting closer to providing a working beta version that we're going to start providing to whoever is interested in further developing this integration. So thanks again for listening through some of these ideas, and I really looking forward to bringing this solution to utilities and contractors to help out, because I see the IKE solution, just my time playing around with the device, it's a huge boost in efficiency, and the more that we can continue to improve this integration, I just see that as a big win-win for everybody. So thank you again, and we'll talk to you again soon.